Okay, so before we attempt to draw the graph, let's quickly go over some theory regarding the straight line graph. So keep in mind that all straight line graphs are in the format of y is equal to mx plus c. So we know that our gradient is the m value, and then the c value is the y-intercept. Now the y-intercept is where the straight line cuts your y-line. Right, that's your y line, and that's where it cuts. So this intersection here is where we call the y-intercept. Okay, in some cases you will not get a y-intercept. For instance, if you draw a line that's called y is equal to x, you will notice that in this format here, if you follow this format here, the gradient will be 1, but the c value is 0. Because if you look at this, it's crossing the origin. So that means on the y line, it's cutting at 0. So keep in mind that not all the time you will be getting a y-intercept. Okay, the other thing is, when it comes to the gradient, we know that when the gradient is a positive, when m is a positive value, right, we know our direction of our line will go that way. When m is a negative value, we know the direction of the line will go this way. Okay, so that's basically more or less some of the theory around this before we actually attempt to draw it. Okay, one of the things that I just want to mention when it comes to the domain, right? So when it comes to the domain, now you know the domain is all the x values. So if I look at this example here, right? If you look at this, the line extends all the way to infinity in both directions. So that means all these are my values for x. So that means x would be in a domain element of real numbers. Similarly with the y, right? If I had to look at this example here, so the range is my y values. So if you had to look at all the y values, right, we will look at it this way. There's my y values here, and remember this graph goes all the way to infinity. So these are all the y values, right, all the way to infinity. So therefore, likewise, for the range, we say my range is y is an element of real numbers. So that's basically some things that you need to know when it comes to the straight line. Okay, something else worth mentioning is also just two things. Is if we had to look at y is equal to x line again, remember it will cross the origin. The origin is the 0 point, 0 and 0. Now if we had to look at this being y is equal to x, right, now something you must note that this is my m value, but if I draw y is equal to 4x, okay, if I draw y to 4x, you'll notice it takes on this shape. So something that we have to realize is this is 1 and this is 4. So the bigger the m value, the steeper the graph. Okay, so that's important just for you to know when you are drawing these kind of straight line graphs. Okay, something to add is if we get two lines like this drawn, right, I have two graphs next to it just like this. Right, remember these are my graphs drawn. So now on these graphs, right, I will have the formulas, but something we must realize that when we work out the m value for this graph, right, it will be identical to this. And in this case, only when it is identical, when the m values are identical, therefore these lines will be parallel. So that's a way of someone telling you to prove that two straight lines are parallel, is to then you need to prove that the m values are equal. Okay, the other other one is when two lines are drawn and given to you, but the difference is, I'll draw this in another color so you have an idea. So you have one line going this way, all right, and the other line would go in this direction. So in a case like this, right, these equations would be given to you. What would happen here is when you take the m values and you multiply it, so we'll say m1 times m2. Now let's say, for instance, we call this m1, we call this m2. So when we take the gradients of these two lines and we multiply it and we get an answer of -1, then this proves that these two lines are perpendicular to each other. That means they form a 90 degrees to each other. Okay, so you're given the equation 3x plus 2y is equal to 6. Now you notice something, that this is not written in the format of y is equal to mx plus c. We know straight lines are drawn in that format, but in this case they've moved the y around and the x around, and they've just basically given you in this format, which is mx plus y is equal to c. That's basically what happened. The idea is still the same, right? So what we need to do is, in the method like this, generally in the exams it's easier for us to use the intercept method. It's faster, saves you time in the exams. So the intercept method basically means, if this is x and y, this is my x and y line, right? It means that I am looking for the two places that this graph will cut the x and the y line. Now I know if it cuts the y line, then x will be 0, so the coordinate here will be 0, y. And if it cuts the x line, then the y will be 0, so the coordinate here will be x, 0, whatever the x value is, and in the same similar case, whatever the y value is. So once I know those 2 points, I'll just join it and I draw my graph. So that's the idea around here, very quickly. So let's find our intercepts. Now in order for us to find our intercepts, so when we're working out the x-intercept, right, all we need to do is, working out the x-intercept, we'll say let y equals to 0, which is basically what I just explained here. Working out the x-intercept, and y will therefore be 0. So let's substitute this in this formula now. Okay, so we have 3. Now we're dealing with y, eh? So x stays the same, plus 2 into 0 is equal to 6. Now let's solve for x. So we have 3x is equal to 6, and x is equal to 2. Okay, now we come to the next one, which is the y-intercept. So let's draw the y-intercept, and then this would be let x equals to 0. So substitute again. We have 3 into 0 plus 2y is equal to 6. 2y is equal to 6, and y is equal to 3. So my coordinates would be, remember, x is equal to 2, so y will be 0, and the other one is 0 and 3. So all I need to do is now find this formulas. So these points. So there's my coordinates here, and I will just look on the lines. I'm not drawing to scale, so I'll just give you an idea. So you look on the x line for the number 3. Right, so once we find the number 3, we've got it here. On the x line, sorry, the number 2, from here I'm working with this now. So the coordinate is, there's 2 there, and this is my 0, so this will be my point. And the other one would be the 0 and 3. So if I'm looking at this part here, 0 and 3, so let's say 3 is there, right, in this vicinity, right? So I'll just call that 3, and all I need to do now is join those lines. So once I join them, right, I have my line drawn there, and that's basically how it's drawn. A good way to check this would mean for us to go and make our equation, this equation here, in the format of y is equal to mx plus c. Why this is important is, if we place it in that format, say for instance, if I had to work in this corner here, I'd say solving for y now, so I'll say 2y from this equation here. Remember, I'm solving now, solving for y because I'm keeping it in this format here. So we have 2y is equal to, now remember the 3x goes on the other side, it will be minus 3x, right, plus 6. Then I'm the all the way I'm the solve for the y, so I have to divide all by 2. So I'll have y is equal to minus 3 over 2x, right, and it will be plus 3. Now something that's important here is this, the value of the m. The value of the m is a negative, so therefore my graph will go this way. And if you look at it in this example here, the graph goes in the similar direction. So therefore I have the right answer, and it cuts at 3, and my y-intercept is 3. It's a good way of you checking to see if you've drawn the right thing.